about this one. This one has my name and my identity on it. There's the second one. So hi, I'm Zat from Hamzatronics Technologies. Today I'll be showing you this project of mine, which is what an ID card based RFID door lock system. I've posted the part 1 of this video before, then this will be the second part of the video. But in this second part, I'll be doing what? I'll be explaining everything all over. Yeah, so this is the system right now. So let me turn it off and turn it on again. Then you can see RFID based door lock. Then we have what? Scan card to unlock. So I make this one, I make it fast. Like there's no time wasting, there's no delay, you understand? It's just instantaneous. So let me show you this. Let me scan this card right now. So this is the printed card I spoke about. This one has my name and my identity on it. There's the second one. So I just put a random picture and a random name as well. So we have this one as well. We have a random name and random picture. So let me scan this first card now and let's see. You can see it make a sound instantly, and it's telling us what? Card not found. Can you see? So I added this sound so that once you scan the card like this, it tells you that what? There is no, it tells you that the card has been scanned. You understand? Once you scan the card, it's what? It makes one beep sound. Pam. That first beep sound tells you that what? The card has been scanned successfully and you can remove it. So can you see? So card not found. So right now, let me do it once again. Card not found. So same for this card. So okay, oh sorry, this one is registered actually. This one is registered. So if I scan it now, can you see? The door is unlocked. So let me lock it now. You can see this threaded lock. So if I scan the card now, you can see it can be unlocked now. So after making some sound, it was to go back to lock mode. So let me scan the card that showed the screen. Card detected, door unlocked. Yeah, door now locked. Then we have scan card to unlock again. You can see. So I've solved the problem of the delay that we were having the other time. So this time around it is faster. So remember, this is the MasterCard. A very funny card. So let me scan it now. So press the switch to use your command. You can see. So then we can press add. So let's scan our new card. Scan the card. And it's telling us what? Card. Oh, sorry, I couldn't catch that. The delay was very short. I want to make everything fast. So let me add another card to show you the screen. So let's scan the MasterCard first, the admin card. Can you see? Press switch to issue a command. I will click what? I will scan the new card. And it's telling us new card added successfully. Yeah, let me scan a new card. Let me do the master's card. Then press what? So let me scan the MasterCard. Then we'll press a switch to issue a command. Then we'll press what? Scan new card. Then we'll have a new card. Then we'll scan. Card already registered. Oh, sorry, I've registered this already. So let me register this. So we have scan card to unlock. We have this card. And I'll see what? I'll scan this card. After scanning the MasterCard, I press the add command. And I scan my new card. Then it's telling me new card added successfully. That's what I wanted to see. So right now, these 3 cards have been registered. And any of them can unlock the door. Can you see? Do you hear that click sound? Door unlocked. Door now locked. So let's test the second card. Yeah. Door unlocked. Door now locked. Let's scan the third card. Door unlocked. Door now locked. Yeah. So now to show you that I've solved the problem I was having the last time with EEPROM. So I've used SPIFs, ESP2 SPIFs right now. So as you can see, this is the ESP2 board, and I also have I have other things like I had them earlier. So this is the BD139 transistor and the what's it called? The resistor going to the base of the transistor. I actually intend to use 2 kilo ohms, so I have to use 2 4.7 kilo ohms in parallel to make something like 2.3 kilo ohms or 2 point thereabout. So we have the buzzer and we have other components like I explained earlier. So let me just leave this on the side. We'll come back to that. So we now have what? We have these 3 cards, right? That are registered already, and we have our master card. You understand? So now let's assume that Mr. What's his name? Mr. Q. I can't pronounce this. Okay, let me say Mr. Akan Sudak was he retired, or he found another job in another company. So he retired, he resigned, and wants to disable his card. You understand? Yeah. So then we can do what? Use this master card, scan it, then press the what? Press the delete button. Press the delete button. So then we can what? Scan the card, and it's telling us what? Card deleted successfully. Can you see now? So the card cannot be used to open the door anymore. You can see card not found. Card not found. So right now we want to what? Hey, like I said earlier, I forgot. I want to show you what that this thing is now working. What is now working offline to it. Like it has it's saving to SPIFs, EFS2 SPIFs memory. You know, that's kind of like what's it called, EEPROM, although it is more advanced, like a lot more advanced, and it doesn't have read and write cycles. You understand? So right now, let me turn off the system. Turn off the system. You can see the system is off right now. Everything is off. There is nothing on in the system. So and now we can what? We can turn it on again. RFID-Based door lock, scan card to unlock. So right now, we removed this card recently, so let's scan it. It's saying what? Card not found, and the door is now unlocked. You understand? So this card is not, it has been removed, so it's not working anymore. And this card was working earlier. You understand? This card wasn't working until we registered it the other time. So let's scan it right now and see if the card is still registered. If it's still registered, that means what? That means the SPIFs is working. It retains the last memory. So let's scan. And yeah, door unlocked. Can you see? Door unlocked. So that means what? The card is working. So that means the card is working on thank God, that's working perfectly. So right now we can add what? We can add card, we can delete card, and what? And we can unlock the door and close the door. So I also added one more charging port. So I added this other TP4056 charging module to ensure that it can charge the battery via Android charger. You understand? So let me do a quick recap of how everything worked just now. So we have the RFID card reader here. This card reader module is the one that has the ability to read this card. Let's leave it that way. That's the simplest explanation for it. So it can read that card and send signal to our microcontroller. And the microcontroller we are using here right now is what? ESP32 board. So that ESP32 board, once it receives that card information, we already have an algorithm inside it that will check if the card is registered. If the card is a master card, it will tell you to press a button. So you can press the add button or the delete button to add or delete a card. You understand? So if you scan a card that is actually registered, that is not a master card, it will unlock the door. You understand? I'll show you the display it was displaying the other time. You understand? So if the card is the card that is not registered, it will tell you the card is not registered. You understand? Card not found. You understand? So right now we now have what? We have, yeah, so that's how that one works. So we have this guy has been explained. The SPT is the brain of the circuit, is the microcontroller, is the one receiving signal from this guy and sending signal to the LCD to print on the screen, sending signal to the buzzer to make sound. You understand? Like make sound when the card is registered or not registered, whatever. You understand? So that card is registered, so it made it sound. So we have the buzzer, like I said. We have the BD139. That BD139, because this solenoid lock cannot be powered directly using our ESP, so we have to use something that can power it, that will serve as a driver for it. You understand? So that's why we are using our NPN transistor, and we are using BD139, which can handle the it can handle the current and the voltage. So we have our 18650 LiAm battery on this side here. This battery is the one we use to power the entire circuit. You understand? So we use just one, since this is just a finite project that won't really be used for that long. You understand? So that means it can't last for several hours. You have to recharge it. So we also have the I2C LCD. So we are using I2C LCD to make it easy to connect and program. You understand? We only have 4 wires coming out of the LCD. So instead of having several wires, we are using the normal, the usual way without I2C LCD backpack. But this I2C LCD backpack makes it easy for us because we only need 4 wires now. You understand? So, and we have what? We have one TP4056 charging module here for charging our battery. So it prevents the battery from overcharging, and it indicates when the battery is charging as well as when the battery is fully charged. So the red LED indicates when the battery is charging, the blue LED indicates when the battery is fully charged. So let me see if I can quickly test that for us. So the LED is an addition to the buzzer, like I said, and yeah, so it works together with the buzzer. So once the buzzer makes sound, we also send signal to the LED to make sound at the same time. So that is that. Then that's pretty much everything here. Then we have these 2 push buttons. So these 2 normally open push buttons. So the 2 push buttons, this one for add, this one for remove. Yeah, I think I've explained that earlier. So for adding and deleting cards respectively. Let me turn off the system. Yeah, so that's that. Then we have this transformer-based power supply requested by the client. So we have the power ports, we have the transformer. The transformer step down to 240 volts, input AC voltage, step it down to 12 volts. Then the 12 volt is fed into the rectifier itself. After the rectifier, we have the filter capacitor that filters out the ripples in the power supply. Then we now have our 5 volt regulator, the LM78XX regulator series. This one particular is what? LM7805, which means the output voltage is what? 05 volts. So, and we have our TP4056 charging module here. So it also what serves as an extra regulator for what? For the battery. So since it's a charging module, so we just feed in the 5 volt input what? We fed it in through the what? Positive in and the negative in. So that is everything in a nutshell. So feel free to ask a question below if you have any question. Let me know. So as you can see right now, it's showing what? It's showing red LED. That means the battery is charging and it is not fully charged yet. You understand? So that is that. So inside this black tape, I have a capacitor and a diode. So the diode is to prevent a flyback current from the solenoid lock. You know, when you're using something like electric motor or electromechanical relay, it's good to add capacitor and diode as a precaution. So we have the LED here. This LED is just an addition to what? To what's it called? To the buzzer. It's an addition to the buzzer. Yeah, so right now this is the system, as you can see here. So let me turn it off and turn it on again.